Hello, in this lecture we'll answer two questions. In the first question, we'll find out the value of line segment X that is in rectangle ABCD. In the second question, we'll find out the value of the green shape that is inside a semicircle. So we'll start with the first question. In the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have a circle. The tangent from point A to this circle is equal to 33 units in its length. The tangent from point B to this circle is equal to 85 units in its length. The tangent from point C to this circle, it is unknown. That is the tangent that we are looking for. So we are looking for the value of x. And finally, the tangent for point D to this circle is equal to 35 units in its length. And our mission is to find out the value of the tangent from point C to this circle that is equal to x according to what is given us the question. We are looking for the value of line segment x. Okay, so first of all, we define the center of this circle as O. We define the point of tendency of the tangent from point A to this circle as E. We define the point of tendency of the tangent from point B to this circle as F. We define the point of tendency of the tangent from point C to this circle as T, and we define the point of tendency of the tangent from point D to this circle as M. We will join points M and E together by a straight line. Point M, point O is the center of the circle, point E is the point of the circle itself, therefore OE is the radius of this circle that we define as R. And we have here rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have tangent AB that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency. Therefore, according to this rule number 1, this angle will be equal to 90 degrees. And this angle will be also equal to 90 degrees. We can implement rule number 1 in our drawing. Why? Because in our drawing we have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and F together by a straight line. Point O is the center of the circle, point F is the point of the circle itself, therefore OF is the radius of this circle that is equal to R, and we have the radius OF that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and T together by a straight line. Again, point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of this circle that is equal to r, and we have the radius OT that is 1 to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. And we join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself. Therefore, OM is the radius of this circle that is equal to R, and we have the radius OM that is 1 to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. In the next step, we will join points A and O together by a straight line. By joining points A and O, we actually created here the right triangle AOE. We will implement the Pythagoras theorem on the right green triangle, triangle AOE. According to the Pythagoras theorem, in the right green triangle, triangle AOE, by PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars. So, in the green right triangle, triangle AOE, the hypotenuse is AE, therefore the square of the hypotenuse, and the hypotenuse, it is actually AO, therefore the square of the hypotenuse is AO square, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to OE square plus AE square. So, according to the Pythagoras theorem, in the right green triangle, triangle AOE, AO square equals to OE square plus AE square. So, AO square equals to OE square. OE is R, so OE square will be equal to R square plus AE square. AE is 33, therefore AE square is 33 square. Okay, so actually, according to equation number 1, we found out that AO square equals to R square plus 33 square. In the next step, we will join points O and B together by a straight line. And we will focus on the yellow right triangle, triangle OFB. In the yellow right triangle, triangle OFB by PT, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BO, therefore the square of the hypotenuse is BO square, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to OF square plus bf square. So according to question number 2, we found out that in the right yellow triangle OFB, BO square equals to OF square plus BF square. So BO square according to question number 2 equals to OF square. OF is R, therefore OF square is R square plus FB square. FB is 85, therefore FB square is 85 square. So in conclusion, we found out that according to question number 2, BO square equals to R square plus 85 square. Okay. In the next step, we join points O and C together by a straight line. And we implement the Pythagoras theorem on the right orange triangle OTC. The right orange triangle OTC by PT OC square equals to OT square plus TC square. Repeat again, in the right orange triangle OTC, according to the Pythagoras theorem, OC square equals to OT square plus TC square. So OC square equals to OT square. OT is R, therefore OT square is R square plus TC square. TC equals to X, therefore TC square is X square. So actually we found out that according to question number 3, in the right triangle OTC, in the right orange triangle OC square equals to R square plus X square. In the next step we will join points D and O together by a straight line. And we will implement the Pythagoras theorem in the right pink triangle TMO. So in the right pink triangle DMO by PT, the O square equals to MO square plus dm squared. Repeat again. In the pin right triangle DMO, according to the Pythagoras theorem, dO squared equals to MO squared plus dm squared. So dO squared equals to MO squared. MO equals to R, therefore MO squared is R squared plus dm squared. dm equals to 35, therefore dm squared is 35 squared. So in conclusion, we found out that according to equation number 4, dO squared equals to R squared plus 35 squared. In the next step, I will copy the 4 equations that we created by using the Pythagoras theorem in a new page. So here we have question number 1 that states that according to question number 1, AO squared equals to R squared plus 33 squared. According to equation number 2, we found out that BO squared equals to R squared plus 85 squared. According to equation number 3, we found out that CO squared equals to R squared plus X squared. And finally, according to equation number 4, we found out that dO squared equals to R squared plus 35 squared. In the next step, I'll copy rectangle ABCD in a new page, and also the circle that is inside it, and then analyze the rectangle with the circle. So we have here rectangle ABCD. Inside rectangle ABCD we have a circle. So this is actually rectangle ABCD. This is a quote from the original drawing. We know that all the angles inside a rectangle are right angles, so this angle equals to 90 degrees. This angle equals to 90 degrees. This angle equals to 90 degrees. This angle, it is also equals to 90 degrees. In the next step, from the center of the circle, that is to say from point O, we will draw perpendicular on AB. Again, from point O, we will draw perpendicular on AB. So this angle equals to 90 degrees, and this angle it is also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB is T. So here, because of the fact that side AB is parallel to side DC, it means that the perpendicular from point O to AB, if we extend it to DC, it will be also parallel to DC. Why? Because AB, the perpendicular from point O to AB will be also perpendicular to DC. Why? Because side AB is parallel to side DC. Okay. So here, that is to say, this angle must be also equal to 90 degrees, and this angle must be also equal to 90 degrees. Okay. And define the touching point of the perpendicular from point O to DC as M. In the next step, from point O, we will go perpendicular on BC. So here, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as N. Again, because of the fact that side AD is parallel to side BC, it means that the perpendicular from point O to BC, if we extend it also to AD, it will be perpendicular also to AD. Why? Because AD is parallel to BC. So here, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to the rule that I mentioned. Because of the fact that AD is parallel to BC, means that the perpendicular from point O to BC will be also perpendicular to AD. So we define the touching point of the perpendicular from point O to AD as H. So here we actually created quadrilateral ATHO. Inside quadrilateral ATHO, we have 1, 2, 3 right angles. The sum of 3 right angles is 230 degrees, plus the size of the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the fourth angle must be also equal to 90 degrees. 1 equals 230 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. So in order to complete the sum of the angles in this quadrangle ATHO to 360 degrees, this angle must be equal to 90 degrees. And because of the fact that quadrangle ATHO has 4 right angles, we will relate to quadrangle ATHO as a rectangle. Likewise, in quadrangle HODM, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. And therefore, quadrangle HODM that has 4 right angles, it is a rectangle. Likewise, in quadrangle TBON, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, and therefore, quadrangle TBON is a rectangle. And finally, in quadrangle ONMC, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, and because of the fact that quadrangle ONMC has 4 right angles, we relate to quadrangle ONMC as a rectangle. Okay, so inside the big rectangle ABCD, we have 4 small rectangles. So we know we define side AH as edge 1, we define side HD as edge 2, we define side AT as B1, and we define side TB as B2. We also note that the opposite sides of rectangle are equal to each other. That is to say, side AT equals to side HO in rectangle ATHO. But we know that side AT equals to B1, therefore side HO must be also equal to B1. Likewise, according to the same rule, side AH equals to side TO. But we know that side AH equals to H1, therefore side ATO must be also equal to H1. Likewise, in rectangle AODM, AO equals to DM, but we know that HO equals to DM, but we know that HO equals to B1, therefore DM must be also equal to B1. Likewise, HD must be equal to OM, but we know that HD equals to H2, therefore OM must be also equal to H2. Likewise, in rectangle TBON, side TO equals to side BN. But we know that TO equals to H1, therefore BN must be also equal to H1. Likewise, according to the same rule, TB must be equal to ON in rectangle TBON. But we know that TB equals to B2, therefore ON must be also equal to B2. And finally, in rectangle ONMC, side ON must be equal to side MC. But we know that ON equals to B2, therefore MC must be also equal to B2. And finally, side OM must be equal to side NC, according to the rule that the opposite sides of a rectangle are equal to each other. But we know that OM equals to H2, therefore NC must be also equal to H2. In the next step, we will join points A and O together by a straight line. And we will implement the Pythagoras theorem on the green right triangle ATO. The green right triangle ATO. According to the Pythagoras theorem, we'll get that AO square in the green right triangle, AO square equals to B1 square plus H1 square. It again, in the green right triangle ATO, AO square equals to B1 square plus H1 square. We join points O and B together by a straight line. And we'll implement the Pythagoras theorem on the yellow right triangle, triangle TOB. In the yellow right triangle, triangle TOB, according to the Pythagoras theorem, we get that BO square equals to B2 square plus H1 square. Repeat again, in the yellow right triangle, according to the Pythagoras theorem, BO square equals to B2 square plus H1 square. Likewise, we join points O and C together by a straight line. And we implement the Pythagoras theorem on the right orange triangle, triangle O and C. In the right orange triangle, triangle O and C, according to the Pythagoras theorem, we get that CO square equals to B2 square plus H2 square. Repeat again, in the right orange triangle, triangle OCN, CO square equals to B2 square plus H2 square. And finally, we join points D and O together by a straight line. And we'll implement the Pythagoras theorem in the right pink triangle, triangle D edge O. In the right pink triangle, triangle D edge O, BO square equals to B1 square plus H2 square. Repeat again, in the right pink triangle, triangle D edge O, according to the Pythagoras theorem, DO square equals to B1 square plus H2 square. Okay, so in the next step, we create 4 more equations. We have 2 expressions for AO squared. This is equation number 1 for AO squared. This is equation number 2 for AO squared. So equation number 1 states that AO squared according to equation number 1 must be equal to AO squared according to equation number 2. So AO squared according to equation number 1 is R squared plus 33 squared and it must be equal to a whole square according to equation number 2, that is b1 square plus h1 square. Okay. Then we create the second equation that states that b whole square according to equation number 1 must be equal to b whole square according to equation number 2. So b whole square according to equation number 1 is r square plus 85 square, and it must be equal to b whole square according to equation number 2, that is b2 square plus h1 square. And we create equation number 3 that states that c whole square according to this equation number 1 must be equal to c whole square according to equation number 2. So c whole square according to equation number 1 is r square plus x square, and it must be equal to c whole square according to this equation number 2, that is b2 square plus h2 square. And finally, we create equation number 4 that states that d whole square according to this equation number 1 must be equal to d whole square according to this equation number 2. So d whole square according to equation number 1 is r square plus 35 square, and it must be equal to d whole square according to this equation number 2, that is actually equals to b1 square plus h2 square. Okay, so created here 4 equations. In the next step, we subtract equation number 1 from equation number 2. So this will be equation number 5. So it is equation 2 minus equation 1. Equation 2, in this side of equation 2 we have r square plus 85 square minus equation number 1. Here we have r square plus 33 square. We finished with this side of the equations. Here we have the other side of equation number 2. In the other side of equation number 2 we have b2 square plus h1 square minus equation number 1. In the other side of equation number 1 we have so it is minus equation number 1, that is b1 square plus h1 square. This way we created equation number 5. In the next step, we will open the brackets of this equation number 5, and we get that according to equation number 5, r square plus 85 square. Here we have minus before the bracket, so it is minus r square minus 33 square, that is equal to b2 square plus h1 square minus b1 square minus h1 square. So here we have r square minus r square is 0, so r square will get cancelled. And here we have h1 square minus h1 square is also 0, so h1 square will also get cancelled. So what is left from equation number 5 after we cancel those two expressions? What is left is actually in this side of equation number 1 we left only with 85 square minus 33 square, that is equal to b2 square minus b1 square. Repeat again, according to equation number 5, if found out that 85 square minus 33 square equals to b2 square minus b1 square. In the next step, we subtract equation number 3 from equation number 4. So it is equation number 4 minus equation number 3. This will be equation number 6. So here, equation number 4, in this side of equation number 4, we have r squared plus 35 square minus equation number 3. In this side of equation number 3, we have, so it is minus r squared plus x squared. In the other side of equation number 4, we have b1 square plus h2 square minus equation number 3 that we have here b2 square minus h2 square. In the next step, we'll open the brackets of this equation, equation number 6, and again that according to equation number 6, we have r square plus 35 square minus r square minus x square. It is equal to b1 square plus h2 square minus b2 square minus h2 square. So in this side of equation number 3, we have r square minus r square is 0, so r square will get cancelled. And the other side of equation number 6, we have h2 square minus h2 square is 0, so h2 square will also get cancelled. What is left from equation number 6 after we cancel those two expressions? In this side of equation number 6, we left only with (35 square minus x square). It is equal to b1 square minus b2 square. In the next step, we multiply equation number 6 by minus 1. And you get that according to equation number 6, minus x square times minus 1 is plus x square. 35 square times minus 1 is minus 35 square. That is equal to minus b2 square times minus 1 is b2 square. And b1 square times minus 1 is minus b1 square. So in conclusion, found out that according to equation number 6, b2 square minus b1 square equals to x square minus 35 square. While according to equation number 5, we found out that 85 square minus 33 square equals to b2 square minus b1 square. In the next step, we get equation number 7 that states that b2 square minus b1 square according to this equation, equation number 5, must be equal to b2 square minus b1 square according to equation number 6. Okay, so according to equation number 7, b2 square minus b1 square according to equation number 5 is 85 square minus 33 square, and it must be equal to b2 square minus b1 square according to this equation, equation number 6, that is x square minus 35 square. In conclusion, found out that according to equation number 7, 85 square minus 33 square equals to x square plus minus 35 square. Here we add 35 square to this equation, equation number 7, and we get that according to equation number 7, 85 square plus 35 square minus 33 square equals to x squared. $85 square is 7,225 plus 35 square. 35 square is 1,225 minus 33 square. 33 square is 1,089. That is equal to x squared. So in conclusion, we found out that according to equation number 7, $7,225 plus 1,225 is 8,450 minus 1,089, that is equal to x squared. And 8,450 minus 1,089, it is equal to 7,361, that is equal to x squared. In conclusion, we found out that x squared equals to 7,361. Here we take out of this equation, equation number 7, and we get that x equals to plus minus the square root of 7,361. So here we have two solutions that are possible for x, the positive solution and the negative solution. But because of the fact that x is a length, s is a length, it must be a positive number. So we take into account only the positive solution. That is to say, x is equal to the positive square root of 7,361, that is actually 85.796 units. Okay, so we actually found out that the length of this line segment x is equal to 85.796 units. We finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in two different methods. Okay, so in the drawing we have a semicircle. We know that AB equals to 6 units. AB is actually the diameter of the semicircle, that is equal to 6 units. We also know that this angle CAB equals to 30 degrees, and our mission is to find out the area, the value of the area of the green shape. Okay, so here, first of all, we will define the center of this circle as O. We know that the diameter of this semicircle is 6, so the radius must be equal to half of it. That is to say, the radius must be equal to 6 over 2, that is 3. That is to say, the radius AO equals to 3 units, and the radius OB, it is also equals to 3 units. In the next step, we will join points C and O together by a straight line. Point O is the center of the semicircle, point C is the point on the semicircle itself, therefore OC is the radius of the semicircle, that is equal to 3 units. So here by joining points O and C together by a straight line, we created here triangle AOC. In triangle AOC, side AO equals side OC. They are both equal to 4 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. Okay, so in triangle AOC, we know that the sum of the angles must be equal to 180 degrees. This angle equals to 30 degrees, this angle equals to 30 degrees, 30 degrees plus 30 degrees is 60 degrees. Therefore, the missing angle must be equal to 120 degrees. In order to complete the sum of the angles in triangle AOC to 180 degrees, this angle must be equal to 120 degrees. Okay, so what is the area of a sector? If we have here sector, this is sector AOB, this is sector OAB. The sign for the area of a sector is this sign. It means the area of sector OAB. The rounded sign is the sign for the area of a sector. So the area of this sector, sector OAB, will be equal to the area. So we know that OA equals to R. It is the radius of the circle that contains the sector. OB also equals to R. That is the radius of the circle that contains the sector. So, and we know that the angle between the legs of the sector is angle theta. So the area of this sector, sector OAB, will be equal to the area of the circle that contains the sector, that is to say pi r square, times theta over 360 degrees. Okay, actually here the ratio theta over 360 degrees gives us the relative percentage that this sector occupy out of the entire circle, and when we will multiply this percentage by the area of the entire circle, that is pi r square, it will give us exactly the area of this sector. Okay, we use the new formula in order to find out the area of sector AOB. So I copy sector AOB here, and we'll use the new formula in order to find out the area of this sector, sector AOC. So this is actually sector OSC that I copied from the original drawing. The area of this sector, according to the new formula, we know that the radius of the circle that contains this sector is 3. So OA equals to 3, OC equals to 3, and the angle between the legs of sector AOC is 120 degrees. So according to the new formula, the area of this sector, sector OSC, will be equal to pi r squared. R is 3, so pi r squared is pi times 3 squared times theta. Theta is the angle between the legs of sector OSC, that is 120 degrees, over 360 degrees. Here 3 square is 9, so this expression in total equals to 9 pi. 120 degrees over 360 degrees is 1/3, so it is 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So I found out that the area of sector OAC is equal to 3 pi square units. In the next step, we'll find out the area of this triangle, triangle AOC. So in order to find out the area of this triangle, triangle AOC, I will present to you a new formula for the area of any triangle. So if we have here triangle ABC, that could be any triangle. This is triangle ABC. We know that side AB of triangle ABC equals to A units in its length. We know that side AC equals to B units in its length, and the angle between side AB and side AC is theta. Then according to the new formula, the area of this triangle ABC will be equal to A times B times sinus theta over 2. We use the new formula in order to find out the area of triangle AOC. So I copy triangle AOC here, and we use the new formula in order to find out the area of triangle AOC. So this is actually triangle AOC that I copied from the original drawing. According to the new formula, the area of this triangle AOC will be equal to AO times OC times sinus 120 degrees over 2. That is to say, the area of triangle AOC equals to AO, that is 3, times OC, that is also 3, times sinus 120 degrees. Sinus 120 degrees equals to the square root of 3 over 2, all divided by 2. 3 times 3 is 9, so in the numerator we have 9 times square root of 3 over 2 times 2 is 4. So in conclusion, we found out that the area of this triangle AOC equals to 9 times square root of 3 over 4 square units. And we have already found out that the area of sector AOC is equal to 3 pi square units. Okay? But what is actually the area of the green shape? For the drawing, it is very easy to see that the area of this green shape will be equal to the area of sector AOC minus the area of triangle AOC. Repeat again, the area of the green shape will be equal to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC, that is equal to 9 times square root of 3 over 4 square units. So I found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, is equal to 5.53 square units. I finish with the first method. In the next step, I'll present to you the second method to find out the area of this green shape. According to the second method, the area of the green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector OCB. Repeat again, according to the second method, the area of the green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector OCB. Okay. So what is the area of the semicircle? The area of the semicircle equals to the area of the circle over 2. That is to say, it will be equal to pi r square over 2. Pi r square over 2. But we have already found out that r equals to 3. Therefore, the area of the semicircle will be equal to pi times 3 squared over 2. 3 squared is 9, so here in total we have 9 pi over 2. So I found out that the area of the semicircle equals to 9 pi over 2 square units. Okay. And what is the area? We've already found out the area of sector of the triangle AOC is equal to 9 times square root of 3 over 4 square units. So the only thing that is left to find is to find out the area of sector COB. So we have to find out the angle between the legs of sector COB. We know that AB is the diameter of the semicircle, therefore AB it is absolutely a straight line. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of AB at point O? We have this angle that is equal to 120 degrees, therefore the missing angle plus the missing angle, in total they must be equal to 180 degrees according to rule number 3. So the missing angle must be equal to 60 degrees in order to complete the sum of the angles on the upper side of AB at point O to 180 degrees. This angle must be equal to 60 degrees. So what is the area of sector COB? I will copy the sector COB in your page and we'll find out the area of this sector, sector COB. So this is sector COB that I copied from the original drawing. We know that the area of any sector according to the new formula, it will be equal to the area of the circle that contains this sector times theta, that is the angle between the legs of the sector, over 360 degrees. According to this formula, we find out that the area of sector COB will be equal to pi r square, but r equals to 3, so it is pi 3 square times theta. Theta is the angle between the legs of sector COB, that is 60 degrees over 360 degrees. 3 square is 9, so this expression equals to 9 pi. 60 over 360 degrees is 1 over 6. So in total, we found out that the area of sector COB equals to 9 pi over 6 square units. Here we divide both the numerator and the denominator by 3. 9 over 3 is 3, so in the numerator we have 3 pi over 6 over 3 is 2. So in conclusion, we found out that the area of sector COB it is equal to 3 pi over 2 square units. Okay. Again, I repeat the formula for the area of the green shape according to the second method. I already mentioned that the area of the green shape according to the second method is equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again, the area of the green shape according to the second method it will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Okay, so we already found out that the area of the semicircle is equal to 9 pi over 2 square units minus the area of triangle AOC that is equal to 9 times square root of 3 over 4 square units. And finally, we just right now found out that the area of sector COB equals to 3 pi over 2 square units. So here we have 9 pi over 2 minus 3 pi over 2 is 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in conclusion this expression in total equals to 3 pi. So it is 3 pi minus 9 times square root of 3 over 4 square units. So in conclusion, found out that the area of the green shape according to the second method equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. In the next step, I summarize the lecture. Let's start with the first question, of course. So in the drawing we have rectangle ABCD. Inside rectangle ABCD we have a circle. We know that the tangent from point A to this circle equals to 34 units in its length. We also know that the tangent from point B to this circle is equal to 85 units in its length. The tangent from point C to this circle is unknown. This is the tangent that we are looking for. It is equal to x, and we want to find out the value of x. And finally, the tangent from point D to this circle is equal to 35 units in its length. And I repeat again, we have to find out the length of tangent x. That is from point C to this circle. Okay. So first of all, we define the center of this circle as O. We have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals 90 degrees. We have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals 90 degrees. We have the radius OT that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals 90 degrees. We have the radius OF that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. Then we join points A and E together by a straight line. In this way, we created triangle AOE. In the right triangle AOE, AO square equals to OE square plus AE square. Yeah, AO square equals to OE square plus AE square. So AO square equals to OE square. OE equals to R, therefore OE square is R square plus AE square. AE equals to 33, therefore OE square is 33 square. So in conclusion, we found out that according to equation number 1, AO square equals to R square plus 33 square. Then we joined points B and O together by a straight line. In this way, we created the yellow right triangle, triangle OBF. Implemented the Pythagoras theorem on the yellow right triangle OBF. According to the Pythagoras theorem, OB square equals to OF square plus FB square. Repeat again, in the yellow right triangle, BO square equals to OF square plus BF square. So BO square equals to OF square. OF equals to R, therefore OF square is R square plus BF is 85. So BF square is 85 square. Then we joined points C and O together by a straight line. In this way, we created the orange triangle TOC. According to the Pythagoras theorem on the orange right triangle, CO square equals to OT square plus TC square. CO square equals to OT square plus TC square. So CO square or C square equals to TO square. TO is R, so TO square is R square plus TC square. TC is X, so TC square is X square. So in conclusion, we found out that according to equation number 3, OC square equals to R square plus X square. And finally, we joined points D and O together by a straight line. In this way, we created the pink right triangle. We implemented the Pythagoras theorem on the pink right triangle, triangle DMO. According to the Pythagoras theorem, DO square equals to OM square plus MD square. Repeat again. According to the Pythagoras theorem, in the pink right triangle, DO square equals to R square plus 35 square. Because MO equals to R, therefore MO square is R square. dm equals to 35, therefore dm square is 35 square. So in conclusion, according to equation number 4, we found out that d whole square equals to R square plus 35 square. Then I copied the four equations that we created for according to the Pythagoras theorem. And then I draw rectangle ABCD again with circle. This is rectangle ABCD that I copied from the original drawing with the circle inside it. Then from the center of this circle, that is to say from point O, we draw perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. But because of the fact that side BC is parallel to side AD, it means that the perpendicular from point O to BC, if we extend it towards AD, it must be also perpendicular to AD. Why? Because AD is parallel to BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the rule that I mentioned. Then from point O, we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. But because of the fact that side AB is parallel to side DC, it means that the perpendicular from point O to T, if we extend it towards DC, must be also perpendicular to DC. Why? Because AB is parallel to DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to the rule that I mentioned. So inside quadrangle ATHO, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrangle ATHO, that has 4 right angles, it is a rectangle. Likewise, in quadrangle HODM, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrangle AODM with 4 right angles, it is a rectangle. Likewise, in quadrangle TBON, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrangle TBON with 4 right angles, it is a rectangle. And finally, in quadrangle ONMC, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrangle ONMC with 4 right angles, it is a rectangle. So, inside rectangle ABCD, we have 4 small rectangles. We define side A edge as H1, we define side edge D as H2, we define side AT as B1, and side TB as B2. Okay, then, according to the rule that the opposite sides of rectangle are equal to each other, in rectangle ATHD, AT equals to HD, but we know that AD equals to B1, therefore HD must be also equal to B1. Likewise, AH equals to TD, but we know that AH equals to H1, therefore TO must be also equal to H1. Likewise, in rectangle AODC, HO equals to DM, but we know that HO equals to B1, therefore DM must be also equal to B1. Likewise, we know that AG equals to OM, but HD equals to H2, therefore OM must be also equal to H2. Likewise, in rectangle TBOM, ON, TO equals to H1, therefore BN must be also equal to H1. Here, TB equals to B2, therefore ON must be also equal to B2. And finally, in rectangle ONMC, OM equals to H2, therefore NC must be also equal to H2, and here ON equals to B2, therefore MC must be also equal to B2, according to the rule that opposite sides of a rectangle are equal to each other. Then we join points A and O together by a straight line. As we implemented the Pythagoras theorem, on the green right triangle, triangle AOT. According to the Pythagoras theorem, AO square equals to B1 square plus H1 square. Again, AO square equals to B1 square plus H1 square. Then we join points B and O together by straight line. We implemented the Pythagoras theorem on the yellow right triangle. According to the Pythagoras theorem, BO square equals to B2 square plus H1 square. Again, in the yellow right triangle, BO square equals to B2 square plus H1 square. Then we join points O and C together by a straight line. We implemented the Pythagoras theorem on the orange right triangle. According to the Pythagoras theorem, CO square equals to B2 square plus H2 square. CO square equals to B2 square plus H2 square. And finally, we join points D and O together by a straight line. We implemented the Pythagoras theorem on the pink right triangle, triangle OHD. According to the Pythagoras theorem, DO square equals to B1 square plus H2 square. DO square equals to B1 square plus H2 square. Okay. Then we created equation number 1 that states that AO square according to equation number 1 must be equal to AO square according to equation number 2. Then we created equation number 2 that states that BO square according to equation number 2 must be equal to BO square according to equation BO square according to equation number 1 must be equal to BO square according to equation number 2. Then we created equation number 3 that states that CO square according to equation number 1 must be equal to CO square according to equation number 2. And finally we created equation number 4 that states that DO square according to equation number 1 must be equal to DO square according to equation number 2. So these are the 4 equations that we created according to what I mentioned. And then we subtracted equation number 1 from equation number 2. Here, equation number 2, we have here r square plus 85 square minus equation number 1, we have r square plus 33 square, and it is equal to b2 square plus h1 square minus equation number 1, that is b1 square plus h1 square. Then we open the brackets of this equation, equation number 5, and we found out that r square plus 85 square minus r square minus 33 square equals to b square plus h1 square minus b1 square minus h1 square. R square minus r square is 0. h1 square minus h1 square is also 0, so we left only with 85 square minus 33 square equals to b2 square minus b1 square according to equation number 5. Then we subtracted equation number 3 from equation number 4. So it is 4 minus 3. In 4 we have r square plus 35 square minus, in 3 we have r square plus x square. Then it is equal to b1 square plus h2 square minus b2 square plus h2 square. We open the brackets of this equation, equation number 6, and found out that according to equation number 6, r square plus 35 square minus r plus minus r square minus x square equals to b1 square plus h2 square minus b2 square minus h2 square. R square minus r square is 0. h2 square minus h2 square it is 0. So in equation number 6 we left only with 35 square minus x square equals to b1 square minus b2 square. We multiply the equation number 6 by minus 1. So minus x square times minus 1 is plus x square, minus 35 square times minus 1, 35 square minus times minus 1 is minus 35 square, and here we have b1 square times minus 1 is minus b1 square, and minus b2 square minus 1 is plus b2 square. So in conclusion, found out that according to equation number 6, x square minus 35 square equals to b square b2 square minus b1 square. Then we created equation number 7 that says that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. here equation number 7 that states that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. That is to say, according to equation number 7, we found out that 85 square minus 33 square equals to x square minus 35 square. We added 35 square to this equation, equation number 7, and found out that according to equation number 7, 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,225 plus 35 square. 35 square is 1225 minus 33 square is 1,089. And 7,225 plus 1225 is 8,450 minus 1,089 it is equal to x square. And 8,450 minus 1,089 is 7,361. So according to equation number 7, we found out that 7,361 equals to x square. Then we took out of this equation, equation number 7, we found out that x equals to plus minus the square root of 7,361. So here we have two solutions that are possible for x, the negative solution and the positive solution. But because of the fact that x is a length, x is a length must be a positive number, therefore we take into account only the positive solution. That is to say, x equals to the positive square root of 7,361, that is actually equals to 85.796 units. Again, the value of this line segment x equals to 85.796 units. We finished with the first question, then I presented you the second question, and we solved the second question in two different methods. In the drawing, we have a semicircle. We know that AB, that is the diameter of the semicircle, equals to 6 units. Angle BAC equals to 30 degrees. And our mission is to find out the area of the green shape, the value of the area of the green shape. So we define the center of this semicircle as O. The radius must be half of the diameter. The diameter is 6, therefore the radius must be equal to half of it. That is to say, the radius must be equal to 6 over 2, that is 3. So OA, the radius OA equals to 3 units, the radius OB equals to 3 units. Point O is the center of the semicircle, point C is the point of the circle itself, therefore OC is also the radius of the semicircle, that is equal to 3 units. So in triangle AOC, those two sides are both equal to 3 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, those two angles must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. The sum of the angles in any triangle is 180 degrees, so in triangle AOC we have 30 degrees plus 30 degrees, that is 60 degrees. Therefore, the third angle must be equal to 120 degrees. What is the area of a sector? If we have here sector AOB, that could be any sector, the area of this sector will be equal to the area of the circle that contains this sector times theta over 360 degrees. The ratio theta over 360 degrees will give us the relative percentage that this sector occupies out of the entire circle, and when we multiply that relative percentage by the area of the entire circle, that is to say by pi r square, we get exactly the area of this sector. So pi r square, that is the area of the circle, times theta over 360 degrees will give us the area of this sector, sector AOB. We use this formula in order to find out the area of this sector, sector A or B. So I copy sector A or B here, and we implemented the new formula in order to find out the area of this sector, sector A or C. We know that R equals to 3, so pi R square is pi 3 square. The angle between the legs of sector A or C is 120 degrees, so it is 120 degrees over 360 degrees. 3 square is 9, so in total this expression equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in total this expression equals to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So we found out that the area of sector OAC equals to 3 pi square units. Then I presented to you a new formula to find out the area of any sector, the area of any triangle. This is triangle ABC. It could be any triangle. The length of side AB is V units, the length of side AC is V units, and the angle between side AB and side AC is theta. Then, according to the new formula, the area of this triangle, triangle ABC, will be equal to A times V times sinus theta over 2. We implemented the new formula in order to find out the area of triangle, this triangle, triangle AOC. So I copy triangle AOC here, and here we have AO equals to 3, OC equals to 3, and the angle between those two sides is 120 degrees. So the area of this triangle, triangle AOC, according to the new formula, will be equal to AO times OC times sinus 120 degrees over 2. AO is 3, OC is 3, and sinus 120 degrees is square root of 3 over 2, all divided by 2. 3 times 3 is 9, so in total, the area of triangle AOC will be equal to 9 times square root of 3 over 4 square units. Repeat again, the area of triangle AOC will be equal to 9 times square root of 3 over 4 square units. We have already found out that the area of sector AOC equals to 3 pi square units, but what is actually the area of the green shape? According to the first method, the area of this green shape will be equal to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC will be equal to the area of the green shape. Repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi, and we have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, so in terms of numbers, it is equal to 5.53 square units. We finished with the first method, then I presented to you the second method to find out the area of this green shape. According to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector OCB. Repeat again, the area of the green shape according to the second method will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector OCB. Okay. The area of the semicircle is equal to the area of the circle over 2. That is to say, it will be equal to pi r square over 2. R equals to 3, so pi r square is pi 3 square over 2. 3 square is 9, so in total in the numerator we have 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units in the first method. The only thing that is left to find is to find out the area of sector OCB. First of all, we have to find out the angle between the legs of sector COB. We know that AB has a diameter, it must be a straight line, so if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have in the upper side of AB at point O? We have this angle that is equal to 120 degrees plus this angle. In total they must be equal to 180 degrees. So the missing angle must be equal to 60 degrees in order to complete the sum of the angles on the upper side of AB at 280 degrees, the second must be equal to 60 degrees. So then I copy as sector COB here. This is sector COB that I copied from the original drawing. The angle between the legs of the sector is 60 degrees, and CO and OB are both the radii of the circle that contains the sector, that is equal to 3 units. So the area of any sector is pi r squared times theta over 360 degrees. And therefore the area of our sector COB will be equal to pi r squared. R is free, so pi r squared is pi free squared. The angle between the legs of the sector theta is 60 degrees. So theta equals to 60 degrees over 360 degrees. Pi free square is 9, so this expression equals to 9 pi in total. 60 degrees over 360 degrees is 1 over 6. So in total, this expression equals to 9 pi. This expression equals to 9 pi over 6. We divided both the numerator and the denominator by 3. 9 over 3 is 3. So in total, this expression equals to 3 pi after we divided by 3. 6 over 3 is 2. So we found out that the area of sector COB equals to 3 pi over 2 square units. And I repeat again on the formula for the area of the green shape according to the second method. The area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units. The area of triangle AOC equals to 9 times square root of 3 over 4 square units. And finally, the area of sector COB equals to 3 pi over 2 square units. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi. So we found out in conclusion that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers it is equal to 5.53 square units. Okay, thank you very much.